I'm Brian Scott.
I'm Gary Troxler.
I'm Justin King.
And I'm Brian Capola.
And this is Calc Perfect.
Dude, perfect.
Ladies and gents, welcome to the rock show. Center spotlight, and we watch the stage glow. Backstage access, but you're seated at the front row. House lights shut off, and here we go. Get up, like a one in a million. Get up, like a diamond, you're brilliant. Get up, oh don't stop believing. You're a star tonight. Like we're working our sheets at night on the way to the show. Cruising in the back of a Cadillac limo. Hit the red carpet plus the velvet ropes. Like we got no access pass to the show tonight. Paparazzi show me in my suit and tie. Campus got me feeling like I'm so alive.
We're meant to be. 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 We're meant to be.
0-0.
Yo, dude, shut up, bro.
Thanks, bro.
Oh, yeah, bro.
Thanks. Let me explain just how I got to be such a baller. Okay, so here we have a diagram of my epic shot. So I started off 9 feet away from the goal, and I ran this way and shot the ball into the goal. So, the problem itself. Justin is 9 feet from the goal and is moving to the right at a rate of 4 feet per second. At time t equals 3 seconds, find the distance Justin will have to shoot the ball to make it in the goal. And find the rate at which the ball is traveling from Justin to the goal. So to start off, we use the distance equals rate times time equation. And so our distance is the rate, 4 feet per second, times the time, 3 seconds, equals 12 feet. So that's how far I ran, as shown here. So then we use the Pythagorean theorem right here to figure out how far the distance is of the ball that I threw. So 9 squared plus 12 squared equals z squared. 225 equals z squared. Square root of 225 equals 15 feet is how far I threw the ball. Now, going back to the Pythagorean theorem, if we derive the entire equation, we can figure out the rate shown here, dz over dt with respect to time, of how fast the ball was moving from my hand into the goal. So taking the derivative of this equation, you get 2x times dx dt plus 2y times dy dt equals 2z dz dt. And then all these 2's will cancel out, and you're left with this equation, plugging in the numbers, 12 feet, which is how far I ran, times the rate at which I was moving, 4 feet per second, plus 0, because 9 was a constant, how far away I was. So this derivative would be 0. So 12 times 4 plus 0 equals 15 feet is how far I threw the ball, times the rate, which we're trying to find. So 48 equals 15 dz dt. 48 divided by 15 equals 16 over 5 feet per second is the rate at which I threw the ball.
What? What was that? You were wondering how Garrett made that shot? Well, I was wondering that too. So let's talk about the average height, okay? So we were taking some shots, shooting it, how we do it, we them calc boys. But here we go.
So Garrett throws the ball from 50 feet away into the basketball net. The flight of the ball is modeled by the equation y equals the square root of x plus 50 plus 6.
All right, let's get this stuff out of here, all right? Anyways.
What is the average height of the ball on the interval -50 to 0?
Okay, here we go, and then here's a cute little photo of Garrett with the trajectory going into the basketball hoop, okay? All right.
So using the intermediate value theorem, given right here on the interval -50 to 0, we have 1 over 0 minus -50, and then the integral -50 to 0, square root of x plus 50 plus 6. So then we have our u, which is the x plus 50, and then the derivative of that is just dx, right? So we have nothing in the front. So then we have the square root of u. So if we take the derivative of that, not the derivative, the integral. All right, so then we take the squiggle of the square root of u, and we have 1 over 50. 1 over 50 times the integral of this, so 2 over 3 u to the 3/2 power. And then we have a separate one over here for the 6 that we took out of the original one. So we have 1 over 50 times the integral of 6, which is just 6x. And so then if we mesh all that together, we have 1 over 75, because that's what that is. It's 2 over 150, which is 175. 1 over 75 times x plus 50 to the 3 over 2 power. And then remember bounds. And then plus 1 over 50 times 6x, negative 50 to 0.
No ticket price, names on guest list tonight. Just flash your pass, walk through all the waiting lines. Selected and destined for the spotlight. Chosen and free, you're born to be. Get up, like a one in a million. Get up, like a diamond, you're brilliant. Get up, oh don't stop believing. You're a star tonight. Like we're working our shades at night on the way to show. Cruising in the back of a Cadillac limo. Hit the red carpet, press the velvet ropes. Like we got no access pass to the show tonight. Paparazzi show me in my suit and tie. Cameras got me feeling like I'm so alive.
We're meant to be. 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 We're meant to be.
Oh, son. That was a dope shot. That was
Yeah,
dope.
it was. Let's break it down from a fundamental standpoint. So the position of a moving ball is given by the distance equation negative x squared plus 3x plus 7. So the question is, at t equals 4 seconds, is the speed of the ball increasing or decreasing? So the distance equation again is negative x squared plus 3x plus 7. So if we take the derivative of that, we get the velocity equation, which is negative 2x plus 3. Derive that again, we get the acceleration equation, which is just negative 2. So then we plug in the t equals 4 to the velocity equation and the acceleration equation. And since both of the values that we get are negative, the speed is increasing.
Chaw.
All right, guys, this is our last trick shot for the day.
This is Calc Perfect signing off.
Wait, guys, what are you doing? What are you doing? Oh my god, no, wait, on your front, stop!
3,
Wait, Mrs. Ron!
2,
No! Wait! Oh my god! Oh!